The next topic is Stokes Theorem. The statement is as follows. If S is any surface, this is bounded by a closed curve C, and if F vector is any continuously differentiable vector function, then integral over C, the vector F dot dr is equal to the double integration over the given surface. This is the curl of the vector F I'll put it in a different way. It's a curl F okay, let's put a bracket to curl. This is curl of vector F dot n cap into ds, or this is also mathematically we can write this in a different format, or the other statement is this: integral over C F dot dr is equal to double integral over the given surface S. This is del cross F. This is the curl dot n cap ds. Okay, this is the statement. Using this statement we can solve many problems. Okay, so now let us look at the problems based on the Stokes theorem. Okay, question number 1 on Stokes. This is verify Stokes theorem for F equals to, this is y into I cap plus z into j cap plus x times k cap. Where S is the upper half of, we consider a sphere here, upper half of a sphere x squared plus y squared plus z squared equals to 1, and C is its boundary. Okay, now let's start with the Stokes theorem's statement. This is integral over C, the vector f dot dr is equal to double integral over the surface S. I am supposed to perform the curl f vector dot n cap ds. So now since we are talking about C as the boundary, it looks like a circle for us, right? Whose center is origin and the radius is equal to unity, right? This is unity because the sphere has been given and the sphere has this radius equal to 1. That's why, right? So here, so according to the problem, this will change. So in this case, so here C is the circle. Okay, C is the circle in say xy plane. C is the circle in xy plane whose center is origin and unit, this is a radius. So it means the radius is unity for the given circle. Okay, so now what we do here is that particular circle which we are writing, therefore the equation of circle what we are talking now is this x square plus y square equals to 1, and there is no z, it's on one plane. Okay, so z is equal to 0, right? Whenever I use circle, we know that we are supposed to jump into the polar coordinates. So we use x is equal to r cos theta. R is 1 here, that's why it is x cos theta. Okay, and we write y equals to sine theta, right? And the range of theta should be 0 less than or equal to theta less than or equal to 2 pi. So when you completely cover a circle, the angle subtended is 360 degree or 2 pi. All right, now uh, let's calculate the dx, because we need to substitute the dx in f dot dr, that equation. So what is dx? Cos theta differentiation is minus sine theta d theta. So y is equal to sine theta implies the differentiation of this dy is equal to, this is cos theta d theta. So we are going to put this in the required equation. So let us start with the first part, that is, right, we'll go to the left hand side of the Stokes theorem. So start with that. So left hand side, it is equal to integral over C, this is the vector f dot dr equal to, let's write the f now. F is equal to, this is y into I cap plus z into j cap plus x into k cap into, we are going to put the, this is dx I cap dy j cap dz k cap. Okay, so let us multiply now. Wherever we have the terms that we can substitute, we can multiply with I into I, right? So this is y into dx, right? There is a integral outside, so we cannot miss that. So this is integral over c y dx plus this is z into dy plus x into dz. But we know that in the above case where we are looking at the circle, there is no z, in the sense the z is equal to 0. So when z is equal to 0, this means dz is also equal to 0. I'll write here. So just one more point, that is z equal to 0 implies dz is also equal to 0. So it means the terms containing z become 0, dz also will become 0. I don't have to calculate that and substitute. So what we do, we'll just write the x and dx part now by looking at this. So I know what I need to substitute now. So you see that there is a y, so that y will be sine theta, and there is a dx which is minus sine theta d theta. Okay, so let us put those values from the above said equations. So we can directly substitute the values here, like, so this is equal to integral, right? Now I know that the curve is obtained by varying theta as 0 to 2 pi, 0 to 2 pi. Write the value of y. Y is nothing but this sine theta into dx. Dx is minus of sine theta d theta. Right? Since z is 0, dz also 0, so we don't have the other terms coming into picture. Okay, so this is equal to, there is minus outside, integral 0 to 2 pi, this is sine square theta d theta. So from the basics we know that this integration has to be performed by using trigonometric identity. So sine square theta is nothing but, this is sine square theta is cos 2 theta minus 1. Okay, I'll take the minus also inside, otherwise it becomes like this. Okay, so I'm going to cancel the minus sign. I'll take the minus sign inside, otherwise sine square theta is 1 minus cos 2 theta by 2, but when minus goes inside, it is cos 2 theta minus 1 whole divided by 2 into d theta. So I take the half outside and then I do the integration. So integration of cos 2 theta is nothing but sine of 2 theta divided by 2 minus, there is 1 becomes theta. So value should be substituted 0 to 2 pi. So this is equal to half of, so when I put 2 pi over there, the first term becomes 0. When you put 0, that's also, in this case, it's 0. So first term is 0 minus, what I do, I put 2 pi and 0. So the value is simply minus 2 pi, out of which 2 cancel. So the answer is minus pi. Let's say this is the left hand side value. LHS is equal to minus pi. Now using the RHS part of the Stokes theorem, I should get the same value minus pi, so that we are proving the Stokes theorem. Alright, so before going to the RHS, we can see that in the equation we have to calculate a curl value. Okay, so let's start with the curl. Curl of vector f, that is equal to del cross f vector. So this is nothing but I j k dou by dou x dou by dou y dou by dou z into the vector f components. So first component is y into I cap, then we have z into j cap, and we have x into k cap. So for this we need to calculate the determinant. So let's write that now. So this is equal to I cap into, so dou by dou y of x is 0 minus dou by dou z of z is equal to 1, then minus j cap into dou by dou x of x is 1, then dou by dou z of y is 0, then plus k cap into dou by dou x of z is 0 minus dou by dou y of y is equal to 1. So every term gets a minus, so this is minus I cap minus j cap minus k cap. This is the del cross f, or the curl. So I need to use this curl over a given surface. Okay, so that means uh, I need to multiply, right, the value of the function over a given surface. Okay, so that surface I can calculate using the ds. So ds vector is equal to, right, surface vector along x-axis it is dy dz I cap, plus along y-axis this should be dz dx into j cap, plus dx dy into k cap. Alright, now I know that z is 0, so dz becomes a 0. Alright, so this implies the double integral over the given surface curl or del cross f vector dot n cap ds should be equal to, now since we don't have the dz components, we are left with only this part, correct? This part can be multiplied with only this part, right? So I'll write this. This is nothing but double integral over the given surface. This is minus dx into dy. Okay, now I need to calculate the area of the circle, right? So this represents, this is what now? This is the area of circle. So area of circle with radius 1. So I can write this is equal to, right? It's pi into r square, right? So this is pi into radius is 1 square. So this becomes equal to pi. Right? So we can say that the value of this is equal to 1 itself. So magnitude wise, if you compare, this becomes equal to the, this is, sorry, there's a minus dx, so it's minus of this into this, so minus pi. So this is the RHS, right? So since LHS equal to RHS, we can say that Stokes theorem is verified. All right, then let's go to the problem number 2 on the Stokes theorem. Okay, so problem statement is verify Stokes theorem for the field vector f is equal to x squared plus y squared into I cap minus 2 times xy into j cap taken around a rectangle bounded by lines x equal to plus or minus a, y is equal to 0, and y is equal to b. Okay, now first we need to understand what exactly is the question and where is this area. So just to understand that, let us try to write a graph. So that is, say like this. Okay, now this is the x-axis, say this is the y-axis. So it says that there are two lines, that is x equal to plus or minus a. X equal to plus a, let me draw that line here. So let us say this is the line corresponding to x equal to plus a. Okay, so I'll write here this is x equal to plus a. Similar to that, there is another line which is said to be x is equal to minus a, say somewhere maybe here. So let us say this is x equal to minus a. So because this point has a coordinate minus a, and y is equal to 0 and y is equal to b are the other lines. So let us say y equal to 0 is the x-axis itself. So this is the line I'm drawing here. This is y equal to 0 and I need another line, that is y equal to b, somewhere here. Say this is y is equal to b. Now they are talking about the area between these four lines. So that has to be, right? See this complete area. So the area we are talking about right now is this. Between the four lines which they have mentioned, right? Whatever is the area between them, we are talking about that. Okay, now let us mark some points, right? For so that we can use it in the problem. So this is the origin. I'll write 0 comma 0. This is located at a distance a from origin. So let me call one of the point as a. So say this is point a, which is minus a comma 0. Let me call this point as b, right? I'm talking about this point. So this point is origin, this point is a. So b is equal to a comma 0. Now this point, right, is say called point C. It is located at a distance a from origin and it is located at a distance b from x-axis. That's why the height is b c. So the point C is a comma b. Then we'll write another point here. I don't want to give a name, which is say 0 comma b, and this point is important. I'll call this is say point D, which is minus a comma b. Right. So now let me change the color so that I can mark the direction in which we are going to move. Right. So it is around this, around the circumference or around the outermost margin of this area is what I want to cover. Right. Using with normally we go with the anti-clockwise direction. So I move this, see A to B, then B to C, then C to D, and then D to A. So the arrow marks which you can see is normally anti-clockwise. Okay, this is the direction in which I am going to move. So when it comes to the Stokes theorem, you can see that. Let me write the Stokes theorem statement now. So it says that integral over C, the vector f dot dr is equal to double integral over S. This is curl of the vector f dot n cap ds. This is what we want to find now. Out of which we'll start with the LHS. So LHS says that integral over the curve C, this is vector f dot dr. Right? Now you see this C is actually the complete path starting from A, B, C, D and back to A. So we can write this particular function as four different parts. That is, first part is I'm starting from A and going to B. So this is A to B f dot dr plus, since they are completely different curves every time, I have to write it as a different equations each time. If at all it was a same curve like the previous case where where we had a circle starting from A coming back to A, we use the same circle. So for that reason, you can see that it was not necessary to split the integrals into multiple integrals. Now we have to do that as right multiple integrations. So one is A to B, then we go for B to C. See, A to B is the same curve. Though I have a midpoint as O, I don't have to split it. So it is completely A to B. Then B to C, it is vector f dot dr once again plus integral, this is C to D, right? It's f dot dr, and then we have plus integral, this is dA vector f dot dr. Okay, now we used this for the in the following fashion. So let us try to calculate the terms one by one, right? So before doing that, let's calculate the f dot dr. So what is f? Vector f is already given, and we can see that this is x square plus y square into I cap. Then we have minus 2 times xy into j cap. Right. So this is the given f vector. Then we need a dr. Dr is x. This is dx into I cap plus dy j cap plus dz k cap. So this implies we can write the vector f dot dr is equal to, so I into I we can multiply, so this becomes x square plus y square dx minus 2 times xy, there is a j, so j can be multiplied with the other term containing j, which multiplies a dy. Since there is no z present or no k cap term, it's 0 into dz, which is 0, so we don't have to write that. Now so we perform the integration one by one, right? So first it is along AB. So when you move from A to B in the given in the graph which we had drawn just now, let's go back and check. Along A to B, you have to first write what is the given function for that curve. What is the function for that? So now it is a x-axis, therefore y is equal to 0 is the curve of that. So along AB, right? So along AB, right, y becomes equal to 0. This means wherever I see dy, that is also 0, because y is 0 indicates dy is also equal to 0. And what is the limit of x in this particular line along this x-axis? I have to move from minus a to plus a, right? Only that is the limit of x-axis, the value of this. So let's just verify. So I have to move along this line from here till here only, not after that. X-axis for this shape, x-axis will not extend beyond that, correct? So that's why we wrote in this fashion. Okay, now let's move ahead. So let's do the calculation now. This means integral over AB, the vector f dot dr should be equal to, so f dot dr is already there, right, in which I need to substitute y 0 and dy 0. This means it's minus a to plus a, because x varies from there, minus a to plus a, right? So when you write, think about these 2 points, make y 0 and also you make dy 0, so the second term will not come into picture. In the first term I am going to have x square plus y is 0, so y square will not come, dx is there, we will write a dx minus 2xy. So since y is 0, that term will not come. It's just x square into dx. Right. So x square dx, when you integrate, you get x cube divided by 3 from minus a to plus e. So you will first write there is a 1 by 3 coming out, a cube minus, so minus a cube, right? So this term is nothing but 1 by 3 times a cube, minus of minus is plus, so this is 2a cube, right? So the answer we can write as 2a cube by 3 is the first part of the integration. Along AB we finished. Then we need to go with BC. So let's go back and check what happens with BC. Along BC. Okay, now let's go back and check. So along BC, right, you can see that the value of x is fixed. X is equal to a, right? X equal to a, and I can also see that the value of y varies from 0 to b, correct? So this is the point which I am highlighting. X value is fixed to e. This is the first point. Second point, y varies from 0 to b. If you make such changes, I am getting this line. I am actually getting this line. So along that line, I am supposed to perform the integration right now. So for that reason, right, we will consider it in this way. Okay. Now let us use the same. Right, along BC, whatever I found from the graph, I am going to update now over here. Okay, so I found that from the given graph, along BC, the value of x is a constant a. Whenever it happens so, the derivative becomes equal to 0. And along this line, 0 less than or equal to y less than or equal to b. Right? These are the changes which I am supposed to do now when I write the second part of my integral. That is integral from this is AB is over, so BC I am doing. Integral over BC, the vector f dot dr should be equal to, right? It is integral. Now y varying from 0 to b. Okay, right. Let's look at the equation. Equation says that x square plus y square dx. Right. So wherever I see x, I write this. But since the dx is 0, first term will not come into picture, right? So let me substitute and show. So this is x square becoming a square plus y square into dx. That is a 0 term. Now then after that I have, right, the second term being minus 2 x is a y, right, into dy. Correct. So this term is a 0. I don't have to write it actually, right? So if you are practiced and you know this concept, you can manage this concept by just looking at the equations. You don't have to write this step, right? Directly we can go to the next step. So this is y becoming equal to 0 to b, right? It is minus 2, I'll write outside, minus 2a I can write outside. It's simply y dy, right? So this is minus 2a y square by 2, 0 to b. So 2 cancels, right? The answer becomes equal to minus of a b square. So second part is done. Now next we go to c to d. All right, so I have to write along, this is cd. Right, when you move along the line cd in the given graph, so I can understand that during in this movement from right to left, the value of x actually varies. I can note that x initially is a because I'm starting from this point, and when I reach d, x becomes minus a. X varies like this, but you see that y is a constant now. I can see that the y value of y is right now. It is b at this point, it's b at this point as well. So y is b. Okay, but x varies from a to minus e. So these are the changes which I need to take care when I write the CD part. So along CD, now I just have to update those values which I found from the graph. So along CD, when you move from C to D, I can see that y value is a constant which is b. This implies wherever you see a dy can be equated to 0. And what happens to x, right? X starts from uh, plus a, it becomes minus e. So plus a greater than or equal to x greater than or equal to minus a. So it should lie between this. All right, so we'll write therefore I, this is CD, is equal to integral a to minus a. See, the x limits are not minus a to a, it is a to minus a. Then I will substitute this. X remains as it is, x square. Y becomes b square into, there is a dx coming into picture. So this is dx minus 2 times x into y, which is b, into dy. dy is 0, as you can see. Okay, so I understand that in this case, this is going to be 0. I don't have to write that actually. Okay, let's move on. Now this is equal to, simply I need to perform x square plus b square dx should be integrated from minus a to a. So let's do the integration directly. The first part is x cube divided by 3 plus b square is a constant, then you are going to get a x over there. So this whole term x cube by 3 plus b square x should be substituted with the value that is a2 minus e. So I'll write the upper limit first. So I write a minus a term first. So this is minus a cube divided by 3, right? Minus b square a. This is the first term. When you substitute minus a over, then minus, put a there. So this is a cube by 3, then plus, this is b square into a. Okay, so both the terms get added. So I have minus 2 times a cube divided by 3 minus 2 times a b square. Okay, this is the answer for the third part. All right, let's go to the fourth part of the curve. The fourth part of this curve is, it's along DA. Just to verify, we'll go back to the diagram. This graph shows that DA is actually located over here. So in that region, right, I have to identify what happens to x and what happens to y. X is actually remains constant at minus a, but y varies. Initially it is b to 0. So y varies, x is a constant. That is a characteristic of this particular curve dA. So for dA I should write what is a constant and then I write what changes. So you can see here x is a constant, x is equal to minus a, and y varies from b to a, b to 0, sorry. All right, so along this curve dA I can write x equals to minus a. This means if you see a dx, you can replace it by 0. Then b, right, it starts from b, y varies between b and 0. Right, now substituting this, we get the integral over dA, this vector f dot dr can be equated to, let's look at the equation and let's make the substitution over here. So this is x is a, so it's integral. So this is b to 0, y starting from b and coming till 0. Let's write the term x square, which is a square, plus y square times dx. You can see that the dx is already calculated as 0, minus 2 times, there is it's 2xy, x is equal to minus a into y dy. So this can actually be directly written like y is equal to b to 0. See, minus of minus will cancel, 2ay dy, correct? So 2a I will write 2a, this is y dy. This is 2a, integration happens with the y square by 2 from b to 0. 2, this 2 and 2 will cancel. So this is equal to, there is a outside, when you put 0, it's 0, minus, this is y square, so this is b square. So the answer is equal to minus of ab square. Okay, now we have these four answers with us. Now in order to get the complete answer LHS, I have to add these four result of these four integrals. Let's do that one by one by verifying this. Therefore the LHS becomes equal to, so I have a minus ab square here. I'll write this is the answer of fourth integration. Then going back to the third integration, this is dA. CD is minus 2a cube by 3 minus 2 times a cube by 3 minus 2 times a, this is ab square. This is the third integral. Then we need to go back to the second integral, that is BC. It is minus 2 minus ab square. Then I'll go back to the first integral which we have performed, that is along AB, 2a cube by 3. So that is plus 2a cube divided by 3. So now we can see that out of these terms, I think the minus and plus will cancel. Other terms are same, ab square, 2ab square and ab square with a negative sign. So this answer is minus 4 times ab square is the left hand side. So once we have the left hand side, we can do the right hand side very easily and quickly. So let's look at the RHS now, what's there in the right hand side. So according to the statement of the right hand side of the Stokes theorem, now we can write this is equal to double integral over S, this is curl vector F dot n cap into ds. All right, so this is now this means that I need to calculate a curl first. So let's go to that part and calculate the value of the curl. So this means curl of vector f is nothing but this is del cross vector f. This is a determinant I, j, k, and below that I should write dou by dou x, dou by dou y, dou by dou z. First term is x square plus y square, and the second term is minus 2xy, and there is no z component. Okay, let's calculate this. I cap into dou by dou y of 0 is 0 minus dou by dou z of 2xy is also 0, right? Then minus j cap into dou by dou x of minus 2x y with respect is minus 2y, and sorry, okay, this is j, sorry, my mistake. I have to perform the dou by dou x of 0, so that is 0 here, not this. So this part becomes equal to 0, dou by dou x of 0 into dou by dou z of that term. Both terms are not going to be considered, so it is 0. Then plus k cap into, yes, now dou by dou x of minus 2xy is minus 2y. Then minus dou by dou y of this term is also minus 2y. So I have only one component, that is minus 4y into k cap. This is the curl of the vector f. Alright, so we got a curl. I need the ds. Okay, so what is the ds? Ds vector itself is written as n cap ds. That is equal to, see, n cap ds whole thing can be written as, this is along the x-axis, this is dy dz I cap, plus along the y-axis the second component should be, so y becomes z, z becomes x, dz dx j cap, plus same thing repeats, wherever you have z it becomes x dx, x becomes y, so dy, j becomes k cap. Now these two terms should be multiplied. This is n cap ds or ds vector. So previous term is the curl, that is del cross f. So double integral over the surface, that is s, the del cross vector f dot n cap ds is equal to the same double integral over the surface. We'll write this surface later, okay, in the next step. So first let's write the del cross f, which is minus 4y into k cap. Take a dot product of this with dy dz into I cap, plus this is dz dx j cap, plus this is dx dy k cap. Since we have only the terms containing the k caps over here, only those terms get multiplied and we don't have to write the other terms. So this is equal to double integral. Now I write the limits at a later stage. So this is now minus 4 outside, because minus 4y is my term. Minus 4, this is y times dx dy. Or what I do with respect to y first, because there is a y term there. So would like to write the term in this fashion. Okay, so first let me say dy, I'll write dy dx. So this is y into dy dx. So here I should write a limit for x, then I should write a limit for y. So since this is a rectangle, I need to scan through the complete area, right? So along the given surface area, I should move completely from left to right, that is x starting from minus a to a, and y is actually sweeping from 0 to b. So that's the limit for this integration. X is minus a to plus a and y is equal to 0 to b. Perform y dy. This is what we get now. So therefore this is equal to minus 4. Keep the x as it is. X is equal to minus a to plus a. Perform the integration with respect to y. So this becomes y square by 2, right, with the limit 0 to b into dx, because we are still left with one integration. But before doing that, we need to simplify this. This becomes minus 2 and this is equal to minus 2 times integral x equal to minus a to plus a, y square becomes simply b square. Correct? Because when you put 0 to y, it becomes 0. B square into dx. So let's write that. So this is minus 2 b square into, there is a x coming into picture, from minus a to plus a. Right. So this is equal to minus 2b square into, when you put x over there, it is x becomes a. Okay, and when you put minus, minus of minus a is plus a. So 2a into 2 is minus 4. There is a b square. So this is the right hand side. So since we can see that the LHS becoming equal to RHS, this says that the Stokes theorem is proved. Okay, all right, let me give a homework problem. Okay, this is evaluate integral over c x y dx plus x y square dy over c defined by the square with vertices 1 comma 0 comma minus 1 comma 0 comma 0 comma 1 and 0 comma minus 1 by using, this is Stokes, by using Stokes theorem. Okay, this is a homework question. Please try to solve by yourself and let me know if you have any doubts.